Hey, I want to talk to you today about solving some one-step equations involving addition and subtraction. And I'm going to go through 4 different examples with you, okay? I know you're familiar with the idea of an equation, what it means, and probably even how to solve it. So maybe this will be a review for you. So let's just look at some examples together, and I'm going to show you how I show my work to get the solutions. So let's look at the first one. It says x plus 4 equal to 10. And you know that when you're solving an equation, it's just like a sentence. You want to know what x stands for as a number. What's the unknown number represented by x plus 4 that gives me 10? And I know most people say, hey, that's 6. But here's how you can show your work. And it's good practice to start with solving simple equations so that when your equations get larger and more involved, you know a particular process to use to find those solutions. So what I'm going to do is I am going to get x isolated by itself on one side. I'm going to do the inverse operation of addition because we want really just 0 to be on this side with the x. X plus 0 equal to a number. So if I do the inverse or the opposite of that, I'd subtract 4, but I'd do that to the other side of the equation. I know that you've talked about balancing equations before from elementary math. This will give me x, 4 minus 4 is 0, equal here to 6. We know the solution is 6. And what's great about equations is you can always check your answer. So I take 6, I plug it back in for x. 6 plus 4 is 10. It works. Let's try another one. Let's look at that subtraction equation over here for number 2. M minus 15 is equal to 20. I want to isolate my m value. So that means I want to get rid of any number that's over there on the side with m. I'm going to do the inverse of the sign in front of the number that I want to move. So I'm going to add 15 to both sides. And then I'm going to work going down the board. I bring down my m. A minus 15, a plus 15, they cancel to give me 0. I can even X that out if I want to. 20 plus 15 gives me 35. So now I'm going to check my solution. Always check your answers with an equation. Plug 35 back in here. 35 minus 15, does that give me 20? Sure does. Let's look over here at a different positioning of our equation. Let's say we have x to the right of the number that's over on the left side of the equal mark. I still want to do the same thing. I want to isolate for x. I'm going to get rid of any number that's over there on that side. So since this is a 20, I'm going to subtract 20. It's like a positive 20. I'm going to do the opposite of what its sign is. So I subtract 20. I come over here to the other side and subtract 20. Now 20 minus 20 is 0. I bring down my x. 32 minus 20 is 12. So I'm going to plug my 12 back in and see if that gives me a correct statement. Is 20 plus 12 actually 32? Yes. These are fun. Let's look at the last one. We have a y minus 3 over on the right side of the equal mark. Doesn't matter where your variable is or where the number is with the variable. You still want to get it isolated. So I'm going to look over at the y and I'm going to say I'm going to get rid of this minus 3 by adding 3 to both sides. 18 plus 3 gives me 21. This was gone. Equal to y. That's what I'm saying I get for my solution. I plug 21 back into the original equation and I check it to see if it works. 21 minus 3, does that give me 18? Yes, it does. Remember, equations are fun, they're easy, and you can always check your work. All right? Thanks.